change the topic because now it's about the veterinary vaccines, and a very special topic because it's about safety testing of veterinary vaccines. And vaccination is the most effective method to protect humans and animals against serious and lossy diseases. But also every vaccination causes a local reaction or an inflammatory reaction at the injection site. And for regulatory or for the licensing procedure of veterinary vaccines, safety tests are mandated by the European Pharmacopoeia and other legal regulations to ensure that the vaccine is safe and that the reaction is not so big. So these tests are to evaluate the extent of a local reaction. And that means that a pathologic examination is required for these tests. And this means that the animals had to be killed or euthanized in frequent intervals after vaccination to evaluate this local reaction. The aim of our study was to find an alternative method for these safety tests. We want to evaluate the extent of a local reaction using magnetic resonance imaging in live animals, and these repetitive over 5 weeks. Additionally, we compare these data with a pathologic examination of the injection site to compare both the MRI images from the live animal and the pathologic data from the euthanized animal. And this all was done in order to reduce the number of animals needed for such required safety tests. It's a larger study, and the part I would like to present you now is about 48 pigs, which were divided in 6 examination groups and subdivided in 3 age groups. So we have 2 groups of piglets, 2 groups of fattening pigs, and 2 groups of gills. We used 6 commercial vaccines. All were inactivated and used for the specific age group. That means that we have 2 vaccines for piglets, which were for Mycoplasma hyopneumonia infections, which were given intramuscular to these piglets. We have 2 vaccines for fattening pigs against parvovirus, and we have 2 vaccines for gills, which were for parvovirus and erysipelotrix rhizopathia infection. This was our schedule. We had the vaccination at day 0 and the MRI examination at day 1, 3, 8, 15, 22, and 29 after vaccination. And at the end of the study, which was day 29, we also had this pathologic examination. That means that the animals were killed and the pathologic examination was performed. Well, there were 2 groups where the pathologic examination was done before. There were one group of gills, which was euthanized at day 15, and the other group, which was from the fattening pigs, which was killed at day 22, because we cannot see anything in the MRI images any longer. But to find the injection site over this whole examination period, we had to mark the injection site prior to vaccination, and therefore all animals were marked 21 days before vaccination in order to find our specific injection point. Therefore, the animals were small at this point. We could lift them, and they were marked right behind the left ear to clearly identify the vaccination site. We had this small circle tattoo needle. This is a circle with a diameter of 0.3 centimeters. It's normal to make the number in the ear, to tattoo the number in the ear, and this is a circle from the 8. And after 3 weeks, this is at day 1 at MRI examination, this pig is anesthetized, and we can see our small vaccination point here. And if we have a closer look, you can see that we vaccinated right inside this tattoo. Otherwise, we were not sure where's our vaccination point, because there are always some scratches somewhere at the pig. And so with this tattoo, we can really guarantee that the pathologist find this injection point. For MRI examination, we need an anesthesia because the pigs had to lay almost 20 minutes without moving. and that would not be possible without an anesthesia. And for Germany, it's the only possible combination for pigs. It's azapiron and ketamine given intramuscular, and this injection was done to the ham muscles in order to avoid interaction with the neck. This is our MRI device. It's a Siemens Magnetome Open. You can see it's an open device, not that tube, which you perhaps know. It's perfect for us because we have more space and we can examine large animals. And here you see a fattening pig inside this MRI device, and we have a special protocol used. We have different image weightenings. If you are not so familiar with it, we use the T1 and the T2 weighted sequence. That means T1 is mainly for inflammatory processes, which you can highlight, and T2 mainly highlights fluids inside the tissue. Additionally, we have two different sequence acquisition directions I would like to show you. The first one is the coronary acquisition, so we made horizontal slices through the neck so we can compare both sides of the neck. And the other direction was an axial acquisition, so we have cuts through the neck, and we also have the top and the lower part. Additionally, we used a contrast agent to highlight inflammatory or local reactions. We have a slice thickness of 4 to 5 millimeters. That's because we have these different animal sizes. For piglets and for fattening pigs, we have 4 millimeters of slice thickness, and for the gills, we used a 5 millimeter slice thickness. For image evaluation, we used a software called Able 3D Deductor software, and we had this whole image, and we divided it into a vaccination site and the control site. We evaluated 5 images of each sequence, and we always started at the vaccination point, which was marked during MRI by a fatty dot. I would like to show you how we did this image evaluation, and this is a T2 weighted spin echo sequence or image of a T2 weighted sequence of a coronary acquisition. And what we can see here is the brain. These are the ears. This is our vaccination site, and this is a control site. And you see this bright signal increase inside the vaccination site, which is fluid inside the vaccination site. This is an image of day 1 of a fattening pig. And then we used the so-called region of interest. So we boarded the largest extent of this reaction, and we used the so-called interactive segmentation, which borders only bright tissues according to the thresholds. You can choose this here, and we only bordered the really bright tissue inside our region of interest. After that, we flipped the ROI to the other side and searched with the same thresholds for tissues which have the same signal intensity as our local reaction on the left or on the vaccination side. And if you do so for 5 images, you can reconstruct 3D reconstruction of this evaluated region. And you have here the vaccination side. This is the control side, and what you see is that there are volumes inside. So we have a larger volume in the vaccination side and also some dots on the control side which have the same signal intensity as our local reaction. Additionally, you can see here this red dot which marks the injection point, so you can see how it looks like in the body. After MRI examination, at the last examination day, we used the gold standard in safety testing, which is a pathomorphologic examination, and therefore the animals had to be euthanized. And then a macroscopic and histologic examination was performed also at the University in Munich. For the statistic evaluation, we used the SAS software package. For MRI, we used the variable volume difference between the vaccination and the control site. So we used the volume of the vaccination site minus the volume of the control site. For pathologic examination, we also only used 2 variables. That means the average extent and the maximum extent of local inflammation. We performed a regression analysis and also a rank correlation. some of the results. For MRI, we found significant differences between the vaccination and the control site, as well as differences between the different examination groups. So we find differences depending on the vaccine we used. And for histopathologic examination, we found that all animals showed a granulomatous reaction. These are the results. What you can see here are the different groups, 1 to 6. These are the MRI results, showing you the T1 weighted. That means the sequence which shows most of the inflammatory reaction. This is a native sequence, and this is the sequence with a contrast agent. And you see the volume difference and the standard deviation, and it's given in cubic centimeters. And you see that we have differences between the groups. Also, you see that we have the pathologic examination with an average extent and a maximum extent, and also there are huge differences between these groups. But if we compare the results, we see that only if we use a contrast agent group, we receive the same results as the pathologic examination. This was also shown by a rank correlation. You see the Spearman correlation coefficient and the p-value, and we only received significant relationships when we use the contrast agent sequence and the pathologic examination. So for these all examination groups, I told you that we have different age groups and we have different injection types, which were due to the different vaccine we used. And so we decided to just have a look on the two groups of piglets, because these two groups of piglets were both 6 weeks old at the vaccination day. They both received an intramuscular injection, and they were both killed at day 29 after vaccination. And what you can see here is the volume difference with contrast agent and the average extent, which is our pathologic variable. And what we can see that these are the red dots, which are from the one vaccine, and these black dots are from the other vaccine. So we have differences between the two vaccines, and we have a correlation coefficient of 0.55. And for the variable maximum extent, we receive an R-square of 0.56. So for all examination groups, we only have small MRI volume differences at the last examination day. But this was because we decided that we stopped the examination when we have no reaction in MRI images any longer. And we have these different animal sizes, which is hard to compare because these are 3 groups, 3 age groups: piglets, fattening group, pigs, and sows. And we have different injection types. For the 2 groups of piglets, we have the same conditions, and we received an R-square of 0.55 to 56 between the MRI examination and the pathologic examination. So to conclude, we found comparable results between the MRI and the pathologic examination. And within animals of the same age group and the same examination day, we found a good correlation or relationship between the MRI and the histopathologic examinations. The pathologic examination could identify the character and the local distribution of our inflammatory process or for the local reaction. But MRI is a method which can show up the whole extent of this local reaction, and which can be performed in vivo at the living animals. So for us, MRI is an appropriate method for the use of safety testing, because it can reduce the number of animals, because follow-up examinations are possible, and we can construct the 3D quantification in vivo of the animal. And with this, we can say that we think that it is enough to have 8 animals per group to get this 3D reconstruction and to control the examination or the local reaction over the whole examination period. And so I like to thank the German Federal Ministry of Education and Research for sponsoring this research, and I would like to thank you for your attention, and I'm happy to take your questions.
Any questions? set the area up with inflammatory cells?
No, we do not know whether there is something, but we have. We know. Sorry, I didn't show it. We have the first group we examined. We had this tattoo 21 days prior to vaccination, and we also had a day 0, or a day -1. So we examined them the day prior to the vaccination, and there was nothing at the neck. So we can be sure that there is nothing. What we can see with our MRI, what's going on there.
So I would think, though, that having broken the skin, even if the dye was an inflammatory, that it might have brought more inflammatory cells to the region before you did your injection. I don't know if very mild things would show up on your MRI.
Of course, there could be something in the skin, directly in the skin, but these reactions we have were, although we have subcutaneous and intramuscular injections, they were deeper in the muscle tissue or in the fat tissue, so there's no reaction in the skin directly.
Okay.
I had one question.
Yeah.
It's a great idea to investigate an alternative model, so congratulations on that side. But I am considering if you have tested the effects of MRI in the long term, because you have stated you want to use this model for long term follow-up. So have you tested the effect in the pilot learning?
Until now,
Because there's too much repetitions of MRI in less than a month.
yeah.
So,
You mean whether we checked it for a longer time? We only checked it until day 29. Now we checked it until day 42, but not longer. And if you look in the pharmacopoeia, you only find this 42 days most of the time, which is the longest day. So we extended our studies to this day, but not longer than 42 days.
and my second question is regarding of the management tools, because I was quite surprised about the extension of the vascular amplification and the extensive zone that is affected in the MRI images. Did you observe any so typical in real pilots and in souls? Once you inject intramuscularly, they go and kick themselves. Have you observed different behaviors in the animals during the experiment?
We didn't check it, yeah, but as we saw these great reactions, we are discussing with our behavior department whether we can check something like that, because if there is such a huge reaction, there must be or there could be something, because they always use the neck for everything, for digging, for feeding, for contact to each other, and so perhaps there is one, but I can't say. So,
Thank you very much.
thank you.
Any more questions?
How much does your MRI test cost?
So yeah, it's only the to run it. It's 50 euro a day. So that's only what we need. This is to run it, because we can stop it every day. We can start it in the morning and stop it in the evening. So it's not that expensive. Yeah, if you have a better MRI, it will be more. It costs, yeah, but you can see more. So perhaps there's a chance, but it's not so expensive if you do it for a year.
To grow a leg for my colleague, because I have to be honest, it's cheaper to buy a pig. 100 euros is the costing of a regular pig. But we are veterinarians. We are talking about the safe pig life. I think that all of it are human doctors. You don't really care about the lives of mouse and so on, but we have our part.
Yeah.
We try to develop alternative approach, but it's quite expensive.
Yeah, it's quite expensive. But if you have an MRI for your dog, it's 350 euros or so. So it's much cheaper to do it for the pigs.
Thank you very much.
Thank you.